So for number 10, make sure that your calculator is in radian mode. All right. We're doing another general solution to this equation in radians. So that's again where we got to figure out how far are our solutions apart and do the plus 2 pi n or plus point or 1.256 n or whatever. Okay. Let's go to y equals. Clear out if you have other stuff there and shut your plots off. All right. This equation is going to be typed like this. 9 parenthesis cosine of x parenthesis squared minus 12. See, lots of distraction out there yet. Not a lot of people doing this with me. Cosine of x plus 4. And y sub 2 is 0. Right? If you can't type it in, you're not going to be able to solve it by graphing, so make sure that you've got it typed in like that. I would probably just do a trig window, zoom trig, so let's do that and see what we get. All right, so that's what our equation looks like. Again, you know, we could zoom in a little bit more to see if is this just touching or is it going all the way through. So let's change our window, the y's. Let's go from -1 to +1. I think it's just touching, but I'm just going to zoom in a little bit. Yeah, looks to me like it's just touching. Okay, so an unusual fellow for sure. All right, so let's find the first positive solution. Let's go ahead and do that. Some of you are waiting for me to do it. You should be doing it. Oops, I think I'm in degrees. Okay, I got to do that all over. Hang on. Yeah, it's supposed to be in radians. Well, you got to zoom trig over again when you go to a different mode. So 0.84. Okay. Now, I don't know whether to call that an up wave or a down wave. Okay. I might call it like left point, right point. So this would be a right point. And then we're finding the next one. Let's find that next one. That one would be a left point, the next one. So find this one. .44, we'll say. Now again, the thing that I have left to figure out is what am I adding, what n am I adding, okay? How many n or what number do I put in front of n, okay? And what the most common mistake that I see for people to figure that out is they want to subtract these two that we found, but they're different kinds of solutions. One's a right point, one's a left point. I have to take a left point minus a left point or a right point minus a right point to figure out how far those are apart. So let's see. Let's go ahead and find this first negative solution, which would be a left point. Find that first negative solution. And I get -0.84. And which one am I subtracting that from? The 5.441. So 5.44 minus -0.84. All right. And what does that look like? You could call it 6.28 or 2 pi. I wouldn't care which one you called it. We seem to have a lot of distracted people, not listening to anything, having conversations in the middle of solving problems. That's why when you look back at it, you go, what did we do? So let's work on our focus here a little bit. Number 11 says, suppose a surface wave oscillates according to this equation, where h is the height of the wave in meters and t is the time in seconds. Find the first two times when the height of the wave is 1 meter. Okay? So in this equation, we want to figure out when this equals 1. Okay? With graphing, which means that in y equals, I'm going to type the two parts of my equation. It doesn't matter which one you type first. So go ahead and type 1. Ayana, you typing with us? And then in y sub 2, 1.3 cosine of pi over 6 times x minus 4. Now, the window that we used for number 10 probably is not going to be great. It might work, but h is the height of the wave. The wave doesn't go real high. The amplitude is 1.3, and t is the time in seconds. So let's set our window from 0 to, we'll go 60 seconds. That might be too long, but by ones. And then from, yeah, these y's should work fine. All right. Go ahead and graph it. Yeah, that works okay. So find the first two times when the height of the wave is 1 meter. So wouldn't that be here and here? Okay. Find those answers and be ready to tell me what those two times are. So what are those two times? 2.68 and 5.32. All right. So again, if you look at this objective, there are a couple that are just numerical answers and a couple that are, you know, the kind of more complicated where we got to find a general solution. Okay. That is